Hello, welcome back to the channel. So today we're going to be doing a problem which kind of combines what we've been learning in physics and math kind of. I'm just gonna I'm not sure if I did do an introduction to basic derivatives, but I'm just gonna explain it again this video just in case, and we're gonna be using that to solve this problem. So kind of like how physics and math can kind of intertwine in a way, right? So we're given here x of t, and that's basically signaling that we have an xt graph, right? We're looking at a displacement graph here, right? And this xt graph, we have negative 60 plus 10 plus 1.5 t squared, and we're asked whether this graph is moving in the positive or negative direction, right? And in order to know that, you're going to have to find the velocity, right? Because velocity is your movement, right? Whether you're moving in a positive direction, positive or negative direction, is going to be dependent on your velocity, right? I mean, you could theoretically find it with other graphs, right? But I feel like finding it from the velocity graph is probably going to be the easiest way, your best bet to solving this, right? So, how can we kind of solve this? Is a pretty easy problem if you know derivatives, but we're going to use the power rule, right? And what is the power rule? That means if we have x to the n power and we take the derivative of that, right? d over dy of this, right? Then, well, what we're going to do is going to be equal to nx to the power of n minus 1. And that's all there is to that, right? So now we have to find the now we're gonna apply that to here, right? We're gonna find the graph of the velocity, which the equation to that, which is the derivative of the xt graph. Because think about it, the slope of the xt graph, which I have talked about in a few videos before, is that the slope of the xt graph is the velocity. And what does that mean? That means that the rate of change graph of the displacement graph is velocity, right? So now we're gonna find it, right? So we have v of t, velocity of over time graph, right? And so we're gonna solve this, right? So negative 60, right? What is that? That's a constant. So there we can kind of think of that as negative 60 times t to the 0th, right? So then the 0 is gonna move down. This becomes 0. So the 60 is no longer part of this, right? The 10, right? Think about it the same way, right? It'll be times t to the 0th, right? Because you're subtracting 1 and you're bringing down the 1, so it'll just be 10 plus, and then you bring down the 2 here, 3t. You subtract 1, and that's it. Yeah, so 10 plus 3t. So now that we have the velocity graph, we can see that this is clearly moving in the positive direction, because this is just a line, right? Y equals mx plus b, right? The m here, the slope is 3, right? So it's moving in the positive direction. It's not negative. So that's how you know that. That's how you know, like, from how you can kind of convert between graphs, kind of intersect what we know about calculus and physics. And yeah, that's it. Thank you so much.